Thank you. It was really great to see BT's engagement in CHERI, and in fact, it needs to be followed by other companies. We need this users' view to help us do the right things. So now, let me welcome Ben Fletcher from Codazip. Ben brings more than 25 years of hands-on SoC experience. He has worked in design, verification, software, and architecture, so really hardcore stuff. And for the past 3 years at Codazip, he has been focused on out-of-order core architectures, performance modeling, and CHERI-enabled SoC development. So thank you, Ben. And so what I didn't mention is that Ben is leading the CHERI Alliance SoC working group, and he will talk about that.
Lovely, thank you. Good morning, everyone. I'm going to talk about our CHERI and SoC working group today. Turns out I know a bit about CHERI, but I don't know how to use the presentation. Other down button. Got it. Cool. Okay. So I'm going to say a bit about what we're trying to do, what we've done to date, and what we're hoping to do next. So what we're doing, well, I think our mission is really straightforward. It's very aligned with the CHERI Alliance mission. We're just trying to make it easier for people who are maybe new to CHERI to start thinking about how they build SoCs and do that successfully. The way we try and do that is not to say this is how you must build a SoC or this is how you solve this particular technical problem. What we're really trying to do is build resources that help educate people, help ramp people up quickly. It's really hard to know what you don't know, and so we're trying to overcome that kind of entry barrier. So what we do try and do is provide materials to give people a good route into CHERI. We have meetings in theory every 2 weeks, but that's not happened this month because of this conference and Embedded World. But we do try and get together regularly. We've got a nice group of people in the working group from various organisations, some individual members as well. And as well as thinking about the documents and resources we can provide and trying to work out the best way to do that, we also sometimes have sessions where we discuss specific technical issues people are facing and try and share an understanding between the group as well. And always happy to have new members. So if it's a useful forum for people and they want to get involved, please feel free to let me know and get in touch. So what have we done? Well, I had a slide remarkably similar to this last year. We've written a kind of general guide to incorporating CHERI. There is a link on the Alliance website, and I've certainly used it with a couple of partner companies to try and get them up to speed. So I think there's some useful stuff in there. Turns out, though, writing a document that ramps someone up in the whole world of CHERI is quite hard. It's a big field. It's quite time-consuming. And so we're changing strategy at the moment. And what we're trying to do next is to work on a series of mini documents. So these are documents that are much more targeted at specific topics. It's hopefully a coherent family of documents, but maybe people want to use them in different ways. We're aiming that each document is actually useful in a standalone kind of context. Maybe people want to read all of them in a sensible kind of sequence, or maybe people want to dip in and out because they've already got a bit of knowledge. It's certainly also easier for us to generate the documents given that they're more targeted. So this is the group of documents that we're envisaging that we'll generate at the moment. The highlighted ones are ones that we have already got drafts of. And they range from hopefully useful documents for people who are really new to CHERI and are learning about it for the first time, including a document that just states the problem space. You know, what is memory safety? What is the issues that CHERI can help us address? All the way through to some kind of walkthrough examples. So we have a document on how a simple CHERI DMA engine might work, where the DMA engine is really a proxy for any kind of accelerator or bus manager that sits alongside a CPU. And so the other thing I was going to do today was just to give you a kind of sample of the kind of material we're generating. So that document about a simple CHERI DMA engine, We start off by just quickly revising what a DMA engine does in a system. So it's a way for software on a CPU to move data around the system by delegating that task to another piece of hardware, letting the CPU carry on with its other work while that data is being moved. So the sequence is pretty straightforward. The software tells the DMA engine what to do. The DMA engine does the job. When it's finished, it tells the software it's done, probably by an interrupt. The CPU handles that interrupt, so acknowledges that the DMA engine is finished, and then the CPU can use that data in the new location. And while the data is being transferred, the CPU is freed up to do other tasks. Now, if we move to the world of CHERI, the picture's largely similar, but there's a few different details. So firstly, the software obviously needs capabilities to access memory locations in the system. So I put some colors on the capabilities. They're not relevant in any way other than it helps me talk about them. So the CPU needs to be able to access the DMA engine's registers, needs to be able to tell it what to do, and they'll probably be memory mapped. So I've got a green capability that allows it to do that. The CPU also needs access to the original home of the data that's being moved and the piece of memory where the data is going to end up, so where the DMA engine is going to put the data when the transfer's over. So first step is that the CPU will use the green capability to configure the DMA engine, tell it what it needs to do, and also give it the orange capabilities. So the DMA engine, because it's a CHERI DMA engine, it needs authority to access the source data and also to write the data into the destination. So the system has to have a way for the CPU to transfer those capabilities to the DMA engine. The DMA engine can then use the orange capabilities to do the transfer, can alert the software that the transfer is complete by using an interrupt. The CPU can then handle the interrupt, but another key detail here is as it handles the interrupt and accesses the DMA engine registers and clears that interrupt, it will also revoke the orange capabilities from the DMA engine, because you don't want the DMA engine doesn't need those capabilities anymore. It doesn't need the authority, and you don't want it erroneously trampling over that memory space in the future. And then the CPU is able to, I need the other down button again. There we go. The CPU is able to use the orange capabilities to access the data in its new home. So that's the kind of guides we're trying to write. And the plan is that over the second half of this year, we'll, on a fairly regular cadence, be releasing those documents. We're working with the marketing team, the marketing working group, to make that happen. And that leaves us a few minutes for questions. I'm a horrible thrower, so I'll let you do the throwing.
Okay. Ben's expecting this question because we talked about it on the way here. Unless I've changed the question. No.
That's sneaky.
So, interoperability. So, yes, you talk about CHERI DMA engine. How can I know in future that any CHERI DMA engine I pick up off the shelf will work with any CHERI CPU that I've made? What are we going to do about making sure they work together?
Yeah, so I think the dream would be that common standards that glue SoCs together and glue components inside SoCs together, like AMBER standards, and that would be extended to allow the transport of capabilities and maybe other functions to make the system work. That isn't how it is today. I think in terms of the working group, the main task at the moment is to provide the educational material, but I think once we've got a nice library of resources for people, we need to start thinking about how we assist the various standards to evolve to include CHERI.
Okay, thanks.
Yeah, thanks for the presentation, but and excuse me if my knowledge of software is not that hard. I'm just a hardware guy. So now you explore the DMA issue about handling the memory. Actually, in sometimes we have actually multiple initiators on the bus. So it's not only the DMA, you could be anything else. Sometimes any serial interface, Ethernet, sometimes even data coming from ADC or data or whatever happens in the embedded system, that we can actually access the memory directly and set data. So how do you see we are enabling CHERI here?
Yeah, so one of the challenges, I think, is having hybrid systems, because, again, the dream is that the chips of tomorrow have CHERI throughout, all the IP is CHERI aware, everything's great. But the reality is we're going to be moving through a world where maybe a CPU and some accelerators have CHERI, but other peripherals don't. And that is one of the topics we cover in our guide. You know, how do you deal with capabilities and tagged memory in a world where you have bus managers that aren't CHERI aware? And there's a set of fairly straightforward rules about when you have to, in effect, revoke capabilities and clear tags if they're accessed inappropriately by a non-CHERI aware bus manager. So that is a challenge, and that is one of the things we're trying to help people with.
Okay, thank you.
One question just from online. We have, why do you need authority to use the DMA engine? If you have the capabilities, why can't you use DMA without authority?
Okay. So if we're looking at an example where you have a CHERI-based CPU and the DMA engine isn't CHERI aware, then in that world, as long as the CPU's got capabilities to access the DMA, then the DMA engine can do what it likes. What we're looking at is a CHERI-enabled DMA where we want the CHERI DMA to also offer the memory safety guarantees, at which point that hardware of that DMA engine has to be limited, so it can't access the memory arbitrarily. It needs capabilities of its own, and that's why the capabilities have to be provided by the CPU.
Hi. Thanks very much for the work you're doing. It seems really important, and I'd like to read the documents, but I'm not sure I have a lot of time. With regard to the DMA engine, my question is, have you thought about temporal safety and what happens if a capability gets freed, or the memory capability is pointing to gets freed during a DMA operation? Presumably you've got someone from SCI on the team, so presumably you have, but I'm just curious.
Yeah, so this example is, a fairly simplistic example. So we hint at the temporal stuff by, talking about the revocation of the capabilities within the DMA engine, but we haven't gone into like all the corner cases in that example. Mm-hmm. We have got another document in the plan, which is how CHERI can support better temporal safety. So that document hasn't been written yet, but that would be the home for that kind of scenario, yeah.
Okay.
Yeah, thanks for the talk. So I was just wondering, I think you mentioned tag transport was one of the planned mini documents. So I know currently we're using like AXI user bits for the tags, which seems a bit ad hoc. Is there like a plan to properly standardize how tags should be like treated in different bus protocols?
I think that would be wonderful, and it's my plan to try and help that happen. I think at the moment, though, the advice we're giving in our document is more about whatever solution you come up with, and user bits is, as you say, a little ad hoc, but it is there and it is available today. Whatever solution you have, it's about the things you need to make sure happen to not invalidate the guarantees CHERI offers.
Okay, thanks.
Okay. Oh, it's still working. One last question then.
Are you going to write in your specifications about IOMMU interactions?
That is also one of the topics that we have a plan to cover, but haven't written yet.
Yeah. Do you anticipate that you will require IOMMUs for CHERI-aware DMA engines?
I'm not sure, to be honest.
I don't know. If I knew the answer, I would tell you. But anyway, but it's a good question. Okay, and sorry, Lon, final comment is, it seems like, in the quest for the CHERI Research Center to provide open source reference designs for these things, that is complementary to having standards. And it would be nice to ensure that we provide one of those. So as this work evolves, we'll try and put some energy into making that happen. So,
Yeah, sounds good.
thanks.
Thank you very much. Thank you. So thank you very much, Ben. And I must highlight again that this is the work of the working group. If anyone has experience in SoC design, architecture, etc., come and talk to Ben, because this is really a very important activity. This leads to IP, recommendations, etc. So it helps enable all the ecosystem around the processor. So it is very important work, and please participate.